Hey guys, it's Jay. This is a video on Taylor series representations of functions. Enjoy. So, I'm assuming all of you know what a Taylor series is, but I will review it. A Taylor series is a representation of a function as an infinite sum of terms that are calculated from the values of the function's derivatives at a certain point. This point is known as the center, or C, and this value will always be given in a question. A Taylor series representation is given by the formula shown here. For the function f of x, the formula for a Taylor series is f of c over 0 factorial plus f prime of c over 1 factorial times x minus c to the 1 plus f double prime of c over 2 factorial times x minus c squared plus and so on. And this is given by the summation and the general term f to the nth derivative at the center over n factorial times x minus the center to the nth power, and the sum of that from 0 to infinity. A quick note is n is the value of the nth derivative, and a Taylor series with center at 0 is called a Maclaurin series. So now that we know what a Taylor series is, and we have the general term to solve for a Taylor series, we can do a practice problem. So here I have an example of a problem you might see. Our function f of x is equal to ln of x, and the question is asking us to find the second degree Taylor series representation of ln of x at x is equal to 1. So before we can begin, we can note the important information we need to know. So first, the question says second degree, which means we'll find the Taylor series up to n is equal to 2. Second, it asks us to find the representation at x is equal to 1, which means our center is equal to 1. So now, to solve for the Taylor series using this equation, we first need to find for the values of f of c, f prime of c, and f double prime of c. To do that, we'll find the values of the function at c. So first we have f of x is equal to ln of x at x is equal to 1, which is equal to ln of 1, which is equal to 0. Second, we have f prime of x is equal to 1 over x at x is equal to 1, which is equal to 1 over 1, which is equal to 1. And finally, we have f double prime of x is equal to minus 1 over x squared, which is equal to, at x equal to 1, which is equal to minus 1 over 1 squared is equal to minus 1. So now we have all the information we need to solve for the Taylor series representation of f of x. We have f of c, f prime of c, f double prime of c, we have the value of the center, and we know all the factorials. So we will use the formula we have written out, which is f to the nth derivative at the center over n factorial times x minus the center to the nth power, and we will do this for values from n is equal to 0 to n is equal to 2. So we'll again plugging into the equation, which is f of x, or t to the second degree of x is equal to f of 1 over 0 factorial plus f prime of 1 over 1 factorial times x minus 1 to the 1 plus f double prime of 1 over 2 factorial times x minus 1 squared. And there you have our second degree, and we only need to solve for this. So we can plug it in, and f of 1 is equal to 0 over 0 factorial plus f prime of 1, which is equal to 1 over 1 factorial times x minus 1 to the 1, which is just x minus 1, plus f double prime of 1, which is minus 1 over 2 factorial, which is 2, times x minus 1 squared. And we can simplify this to x minus 1 minus x minus 1 squared over 2 is equal to t of x, which is equal to the Taylor series representation of ln of x. Thank you for watching.